All right, so this last section, like I said, we're going to do password encryption and make sure that password never makes it to the front end. So we want to get the user's plain text password, whatever it is. We want to convert it into an encrypted password and save that in the database. And then whenever they log in, we need to pull that encrypted password from the database, decrypt it, and compare it against what they gave us. So this is going to involve writing two methods. Password encryption, we're going to have to write two methods that do this for us using bcrypt. And then we'll write a third method that removes the password before it sends it to the front end. So let's start there. We're going to go back to our models, and we're going to go to our user model. And this is when on my back end, token export, let's solve an error. We'll figure that out in a minute. We're going to npm install bcrypt is the name of the package. Now sometimes bcrypt, I have the issue where I'm installing it and something doesn't install correctly. So if you ever run your program right after installing and writing stuff for bcrypt, try reinstalling it because every once in a while I have issues with it working right away. Bcrypt. So let's look at crypt. There you go. All right, so in our user model, whenever we declare a model, so far we haven't been customizing them at all. We have been writing the blueprint. This is like writing the constructor function of a class, right? What's this.name, this.color, this.hair color. But you can also add methods to your models. So things that you can use inside of your routes, such as in our auth router right now, we can say new user.save or user.findOne. These are all methods built by Mongoose. We can add our own. So somewhere in here I could say user.myownMethod and call it, and it would do something with that current user. So we can write our own methods, kind of like when we're setting up a class. It just looks a little different when you're working with Mongoose. So there's two types of methods we're going to write. The first one is a hook, and the other two are just basic methods. They're just proper things that we can call. The difference between a hook and a method is hooks are pre-programmed to fire at a specific moment in time, where methods, you have to manually call them to make them work. So we're going to write a hook, and whatever we write here is going to automatically happen at the time we choose. And what the hook is for, it's going to be a pre-save hook. So right before we save something to a database, it's going to take the password, encrypt it, and save the encrypted password. That's the little logic we're going to write. And we need bcrypt to do that. So I'm going to pull bcrypt in. And we can work on our pre-save hook to encrypt password. Now this uses a lot of callback functions, kind of some interesting syntax, so we don't get it right away. Just be working with these methods as you're implementing it, and we'll cover it again. So let's look at this. So to add a hook to our user model, we actually add it to the schema itself before it's exported as a model. So I will say user schema. And there's a couple different types of hooks you can add. I don't know if they'll have any of these. Oh yeah, like on or off. We're going to be using the pre hook. So we're going to say user schema.pre, and then we say before what? Well, before you save, do the following function. So now whenever we're going to save a new user, so this will only ever happen on sign up, right before the save function fires, which is this one right here, right before this actually executes, this is going to hook in and run this code first. Now this is really important. We need a function next, but we have to use the function keyword. We have to use it. Does anyone know of why you'd have to use the function keyword as opposed to just an anonymous arrow function?
What has more than one
word?
Oh, because you don't want to return to. Oh, you use this function.
Okay, so the big issue is we need the keyword this. We've seen this in different contexts, but this, when we're calling a function on an object, so this function is going to be called on a specific user object. This refer to the user this function is being called on. If we don't use the function keyword, fat arrow functions don't get their own this context, so this would be undefined. So even though all the code in here would look the same, if we use this syntax, it wouldn't work, but using this syntax, it will. This gives us the this keyword. So yeah, that's right on. So we're gonna make sure we memorize this by pulling this and calling it user. Because that is who we're dealing with. This inside of this function refers to whichever user this function is being called on. Now this is the object the user sent us, so it's going to have a .username and a .password. And we're concerned about the .password. Right now the password, .password is still just the plain text string. So before we actually encrypt out here, there's a line we have to write for bcrypt's sake. We have to say if not the user is modified, password, return next. And me and Martin went on a rabbit chase to see what this meant, and we came to some conclusion, and I've forgotten. Yeah, if you look up this line for anyone that's like, hey, if you're using bcrypt for password encryption, the most explanation I see for this is make sure it's not make sure it's the first time a password is being saved or something like that. It's just letting bcrypt know, hey, does this user already have a password? Now, since we're in a pre-saved hook, hopefully that means that they don't exist yet. But
you can save it at any time, right?
If the password wasn't like required, I think, or maybe.
If you're doing a put, can you save the put?
You do a update, find one update. But you could, yeah, you could do .save in there as well. So yeah, this is something Crypt needs for that purpose.
I think it's making sure that the password exists before it doesn't exist. Because you're saying
making sure that this object has a password before we go and try and encrypt it. Yeah, so we're just going to keep moving on here, as this is what happens every time we talk about that line of code. Next, we encrypt the password. So this is going to use a method called bcrypt, spelled correctly, .hash. And that's using this bcrypt package. And what hash does is it takes the plain text word, or plain text string, which in this case is the user's password, and then it takes a salt rounds amount, which this means something with the algorithm it uses for encryption, how many times it goes through this algorithm, and 10 salt rounds is pretty standard. It will go and encrypt this password and return either an error or the hashed password. So we're going to get one of these. Just like regular node handling, we need to handle the error first. But we're not going to res.send it here. We're just going to, if there is an error, call our next with the error. Just like all of our other error handling, this will make it to our error handler. But if there wasn't an error, we need this user's password to now be this hash instead of the plain text. So we'll reassign the user's .password to be the hash. And then we'll just call next to move on to the next thing. And this says end the pre-save hook, go on to actually save the user in the database. So overwrite user's plain text password with hashed password, and then move on to the .save in the signup wrapped. Now this is the only bummer part about this is if you've been building a database up to this point, I'm sorry, you're gonna have to delete all your users, because does any of your users have a hashed password yet? No, not until you write this. So at this point, you don't open Spotify, you open MongoDB Compass, you refresh, you go to your database and you say users, I don't want any more plain text passwords. I hit the trash can and drop my users collection. It's gone. Now we're just seeing to-dos. Now we can test this and make sure we're getting encrypted passwords back. So note them on server.js. There we go. And we're going to go back to Postman to do this. So auth sign up, rid of the token. Nope, A, and password, A. So we'll sign up here, and what we'll get back, should get back, is our token, but notice what the password is now. I sent the password letter A, it sent back this. And this is actually what's saved in the database, so not even the database knows what the user's password is. Only our server has the ability to grab this password, decrypt it, and make sure it's the same. So now it's saved encrypted, that's part one. But now what is the problem with login? If I try to log in with password A, what's going to happen?
Error cannot be found.
Username or password are incorrect. Yeah, because if we go back now to our auth router where login is, notice how we're checking the password. We're saying, hey, after you find the user in the database by this username, C, does the user exist? Or see if their password doesn't equal the one that they're sending to us. But now, user.password, this is the encrypted password, and this is still their plain text password. So now login's broken, even though they can sign up. So instead of just doing a little if statement here, we need to write our own method that decrypts the password, compares it to the user's submitted password, and then returns a Boolean saying, yes, true, it matches, they're authenticated, or false, they are not. That is another thing we're going to add to the user schema. We have our pre-save hook to encrypt the password. Now we need one of our first methods to check the password. Any questions up to this point? This is all we've added so far. So it looks a little bit, I know, interesting. Okay, then methods. So we got .pre to make a hook. For methods, we still use the user schema, but then we say .methods, and whatever comes after this dot is the name of the method we're creating. So we're going to make a method called check password, which is equal to, which is important again, using the function keyword, it's equal to a function. And this function is going to take two arguments. It's going to take the user's password attempt. It's going to take a callback function, which we're just going to call callback. While bcrypt has a .hash to encrypt passwords, it has a .compare to decrypt and compare passwords. So that is what we're going to call first. We're going to say bcrypt .compare. We want to compare the password attempt from the user against this .password. Because this .password is the user object this is getting called on. This .password, this is the encrypted one. This is the plain text one sent in the post request. We will give it both of those things, and it will return to us either an error or a Boolean, which we'll call isMatch. And this will be either true or false, but these two things compared are the same. This is the one time where error handling will look a little bit different, and we'll come back to this and see why. But we're going to say if there is an error, then return our callback with the error. But if there was not an error, we're going to use our callback and pass in as the first argument and send isMatch as the second argument. And arguably, it's kind of hard to see what's going here until we go to the router and kind of check back and forth on what's happening. So check password. You need to go to our login route to put this in, and remember it takes the user's password attempt and a callback function as the second argument. So now we're going to not just check the plain text. We're just going to see, does a user by that username exist? Then we're going to see, does the user's password match? And so using my user object that I got from my find one on the login, I'm going to say user.checkPassword using the function I just wrote. And what are the two arguments it needs again? Password attempt and the callback. Yeah. So the password attempt, rec.body.password. And the callback is just that, put a function in here. Interesting, right? Well, what will this callback give us? What does check password do with this callback function? It can return one of two things. It'll either return an error as the first argument, or null as the first argument, and is match as the second. So we can first see, is there an error? If it's truthy, let's just handle it. If there's not an error, then let's check the Boolean and see if it matches. So this will give us either an error or the is match Boolean. So we can check if there was an error, res.status, probably 401 unauthorized, and return next with the error. But if there was not that, we can then see, does it match? So this will be true or false. We can say if it is not true, return res.status 401 as well, and .send. What would be a good thing to send here if the password doesn't match?
Password incorrect.
Username or password are incorrect. Yeah. Which actually this project has handling errors. Let's do it how we've been doing it to stay consistent and not make things harder than they need to be. We're going to say return next with a new error that has this message. Okay, there we go. That's more consistent with what we've been doing all along. If they make it to this point, what does that mean? It's a match, and we've already made sure they exist. So it's a match and they exist. Hey, they're authenticated. So we can take our token and the user send and just paste it here afterwards. Right, so I changed a little bit, right? We were handling the username and, or the user and the password check here. But since we need to now decrypt the user's password and compare it against the one they're submitting, we had to write this method that takes these submissions. So it will take the password attempt, it will compare it against the user's encrypted password, and then either give us an error or give us the is match. So we receive that in the callback here. We check the error, we check if it's not a match, if so, we authenticate them. If you're like, this is way too much to remember, great. Here's the code in part 3 for how to implement check password. Here's the code for the check password function. Here's the code for resetting. So you have the help. So now we can try to log in now to see if this works. Let's try to log in as AA. There we go. We are authenticated. It compared the letter A to this and found that they were the same. Question on this method. If it's the wrong password, so like the letter B, yeah, let's check it. Cool. That's not correct. And what's funny is even if you, like I'm gonna fool them, I'm gonna take the encrypted password and send that as a password. Little do they know, it's not correct. Because when this gets compared or, you know, compared against the decrypted, we're now comparing this to the letter A. So they still give us the regular data, and we make sure it matches the one in the database using decrypt. Yay. And that is it for the back end. There's everything you need for the back end for full security in that sense. But what is still happening that we don't want on the front end? The password, right. If I log out, and let's log in under AA and go look at local storage. We have our user object. And sure, it's going to be a lot harder to break into their account now, even by seeing the encrypted password, but we don't want them to even have that chance. We don't want this to ever be available on the front end. So we have one more method to add to our user schema. We won't change the logic, we'll just change what we're sending back. So this one is for comparing the encrypted password to the user's password attempt. And this one will be for removing the password from the user object before sending it to the front end. What would be a good name to call this method? Remove password or without password, or yeah, something like that. I'm going to go with this. Either of those would work. And we're also going to want the function keyword here as well, because what is the main reason we'd want this? For this, yes. And what is this? In this function, what is this equal to? The user object. User object that we're calling this on. So to make sure this is seen, we're going to say const user equals this. But at this time, it's not an object, so we can't really remove anything from it. So we're going to turn it into an object. And I don't know if you've ever seen this keyword before. It's just a part of Java. You can say delete, and then put an object after it, and we'll delete that from the object. We want to delete the user's password. It's saved in the database. Strip it out of the object before you send it to the front end. And then we will just return our user. So this is a function that will, whatever user is called on, it will turn them into an object, delete their password, and then return that object. So in my routes, anywhere I'm referencing the user object and saving it or using it in some way, I'm going to delete their password. There's 4 places to do this. It's always when we create the token and send the response, we're encrypting the entire user object in the token, including their password. We don't want that, so we're going to send the saved user without password. And when we're sending the user to the front end, we're going to send it without password. And then we just need to repeat this for the login request. Without password. And now we have to say user is user.without password.
So to object is without password.
Any questions on that method? All right, we don't want their password in the token. We don't want their password going to the front end. So those are the 4 places we're calling without password. So let's try to log in again. Great. No password. But we know the password exists. I can sign up under a different username, like ZZ. And I won't get their password. But just the fact that I log in using that password in the database, we're just never showing it to anyone. So you can go to Compass and see, we can see it here and only here. Okay. So we did have to add a little bit, but it's mostly in regards to these 3 methods. That's what part 3 does. This is how we add our security to the user object. Any questions on either of these? I'm expecting some later when you're using them, but anything I can cover here or re-clarify. Okay. The last piece of this is on the front end. We are going to make sure if they mess up on logging in, that we let them know set up a login page that, hey, you done messed up, please try again. And let that show up in a nice way. So here we will go to our provider. Why the provider? Why the user provider? Well, yeah, this is where they're logging in or signing up. So if an error occurs in either of these two interactions, it's going to happen right here. So we don't just want to console log them anymore. We want to save them in state and display them to the user. So I'm going to add a auth error message to state. That is empty, and I'm going to make sure I'm providing it, which I am by spreading state, so we're good there. And now I could write the same function twice to say, hey, save the error in state and then save the error in state, but I'd rather write a little method that does that for me, so I only have to write it once. So I'm going to write a method called handle auth error that receives an error message and saves it to state. Okay, so it's a really small helper function. It just gets a message and saves it in state. But now in both of these, instead of console logging the error, I can call this method and give it the message, and it will save it for me. But let's make sure we know what these error objects look like. Where is the message going to be saved? Let's fail logging in. I'll say A and B. We're console during that error, so here it is. This is what our catch is receiving. So it's error.response.data.error message. That is the actual message we want to save in state. This whole object is the error. That's what we're seeing here. So error.response.data.error message. So I'm going to say this.handle auth error and pass in error.response.data.error message.
Jeez.
And do this for both sign up and login. Right, so whether either of these have an error, we pass to this handler and saving it in state. So let's see if we can see that. Let's fail on a login again, say AB. Fail, go to our React state, find our user provider, and see auth error message in state if username or password are incorrect. So I have it. I now just need to make it show up on the sign up and or login page. Well, we're almost there then. We already have these methods. We're already sending the auth error message down, so we just need to go to our where we're consuming. So let's start at the top and see where we need to pass props possibly. Go to app. App is consuming, it's providing all these props. And let's see. Here is the login page. Is auth consuming? It is. So it has a this.props.error message. So here's our sign up form, here's our login form. I'm going to add a little, maybe I'll do it below in this case. And I'm going to display this.props.auth error message and do this as well for the login. And just so it's really noticeable, let's do this. Style, color, red. Now I'm going to fail at logging in again. A, B, login. Awesome. Let's refresh and try to sign up under something that already exists. Awesome. I know my voice may not reflect it. I'm really stoked this worked the first time. Right, and this shows you that we don't always send successful data to the user for a purpose. We send errors to the user for a purpose as well. So when you're crafting errors on your back end, you have to think like, what's the best thing to do here to let the user know that username is already taken? Like they're going to see this text just as if we hard code it into a span tag on the front end. Now there is this issue where the error message stays even if you go to the other form. So we could write another method that if this toggle is called, we reset auth error message to an empty string and then give them another shot. This is more user experience, but this is getting it to actually show up. And very little had to be added. One piece of state, a handle auth error helper that takes a message and saves it, and then calling that in both of our dot catches with the error object so that it gets saved appropriately. That's the last part. Now there's a lot of things we could do to refactor, but the logic would stay the same. It would just look different. Technically protected routes were in part 3, but we covered that already as far as being able to redirect users. So this is really it. What kind of authentication things would you want to add up past this? What things would you be expecting on the website? Yeah, you can only try to log in so many times. So there's a challenge. How do you, store that?
Password reset.
Yeah, resetting the password. Now, learning what you have with bcrypt. We'll be learning with bcrypt. We've learned how to hash passwords and how to compare passwords. So using these two methods, you could write another method called reset password that makes sure that they entered in the right one and then creates the new one and does the put request to save it in the user object. So using these tools, we could work on those further user experiences, but this is about as far as you'll need to get if you want something solid user authentication wise. Okay.